in the last video I left off, I'm about to talk about fracture repair. So fracture repair of bones, we'll talk about the different types of fractures next, but there are 3 phases and 4 steps. This second phase here has 2 steps to it, okay? So first is the reactive phase. This is like the early inflammatory phase / bleeding phase, okay? So say we have our bone here. We have a break right there, okay, in the center. First, during our reactive phase, a hematoma forms. So it's like a big blood clot forms at the site of the break. So it helps to kind of stabilize the break. So it's like an initial reactive phase, right? Like an initial reaction, we need to stabilize this break, okay? Then in our reparative phase, we have 2 steps. So first is the fibrocartilage callus formation. So this blood, let's use a different color here. One sec. This hematoma is replaced with fibrocartilage. So it further helps to stabilize that break. Okay, so now we have our fibrocartilage callus forming. Then our third step, part of the reparative phase, is our bony callus formation. Okay, so then this is replaced, let's use green for this one. This is replaced with bone. Okay, and then we have this bony callus formed now. Okay, at the site of our break. Then the final step is bone remodeling. So this is taken away, this callus is removed, and then you can barely tell that there was a break there. You'll still have like a little line there maybe, okay? So your osteoclast would come in and get rid of that bony callus, and then we'd have our bone almost fully remodeled. Okay, so those are the steps of fracture. So let's talk about the different types of fractures that can happen. So our first one is known as an open fracture, okay, also known as a compound fracture. And this one just means, it's a very general term, it means that the bone has pierced through the skin, okay, open or compound, the bone has pierced through the skin. Next we have comminuted. In this type of break, at our site of the break, the bone breaks into a few different pieces. Okay, so you'd have different pieces at the site of the break. Comminuted, you'd have a few different pieces of bone at the site of the break. Next is green stick. This one only happens in children. So if you ever played with those little thin green sticks, if you break them, one side breaks and the other side still stays intact, but it could bend. Same thing happens in kids because their bone still has lots of cartilage to it. So if they have a break, this part bends and one side breaks open only. Okay, so again, this one only happens in children, green stick. Okay, then we have impacted, and this one's just like what it sounds like. This is where the bone breaks in two and one part of the bone impacts into the other, or is driven into the other. Okay, impacted. Then we have a pop fracture. This specifically happens at the ankle, at the fibula, the bone on the lateral side of the leg here, toward the bottom, okay? And then a Colles fracture. This happens on the lateral side, on the lateral bone on the side of the wrist. So this bone here is the radius. So it'd be a break specifically right here near the wrist, okay? So those are the types of fractures that you need to know. Okay. All right, now let's talk about how the bone helps in calcium homeostasis in the body. Okay. So we have 2 hormones, parathyroid hormone and calcitonin. Don't get this confused with calcitriol, which is something else, okay? Which we'll talk about. So if we have, okay, not enough calcium in the blood, so if we have low blood calcium. Parathyroid hormone is going to be stimulated by the parathyroid gland to be secreted. So parathyroid hormone will be secreted. Okay, if we have low blood calcium. We want to get calcium then from our bones if we don't have enough from our diet within our blood system. Okay. All right, so this is going to help us increase our blood calcium levels. So how does it do this, right? So in bones, it stimulates osteoclasts. Remember, osteoclasts break down bone. So it stimulates osteoclasts. And they'll come in and break down bone and release calcium. So this leads to increased blood calcium. Okay. They also increase the effects of calcitriol. And remember, calcitriol, or let's talk about calcitriol. So calcitriol helps us to absorb calcium from what we eat. So it increases, it's made by the kidneys and it helps us to absorb more calcium from the food that we eat. Okay, so if we have increased calcitriol production from the kidneys, then we would have increased blood calcium because we'd be absorbing more calcium from our food. Okay, now if we have enough blood calcium, we want to build back our bone. Okay, we don't want our bone to just keep being broken down, right? We need to build it back up. So once we have enough blood calcium, then calcitonin can come in. Okay, this is secreted by the thyroid gland. Okay, and this is going to decrease our blood calcium levels. So it decreases osteoclast activity. Decreases osteoclasts. Now they can't break down bone anymore, so osteoblasts can come in and build up bone. So we would have decreased blood calcium. And also increased, I'm not going to write it down, but also increased calcium going into the bone. So bone is being built back up. Okay. It also decreases parathyroid hormone. So parathyroid hormone is no longer being produced, which would therefore decrease calcitriol being produced by the kidneys, and that would decrease our blood calcium levels. Okay, so these two hormones, calcitonin and parathyroid hormone, work oppositely to each other, but they also work together to help to maintain the proper blood calcium levels and proper building back up of bone. Okay? Okay, so now let's talk about some homeostatic imbalances that can occur. So these are usually caused by endocrine issues. Okay, so these are homeostatic imbalances that affect bones growing too thick, too long, or not growing enough. Okay, so the first one is achondroplasia. So remember, chondrocytes are what make up cartilage. Okay, so this affects the epiphyseal cartilage. So it's when it grows very slowly. Okay, so the limbs would be short in achondroplasia. Okay, pituitary growth failure, exactly what it sounds like. There would be a reduction in the growth hormone, so you wouldn't grow as tall. But nowadays we can fix this by giving growth hormone to the patient. Acromegaly, this is overproduction of growth hormone, and this causes bones to grow thicker, not longer. So you wouldn't be abnormally tall, but it mostly affects the jaw and the hands. So the jaw and the hands could grow a lot thicker, so it makes your face look a lot larger than it should be, and your hands as well. There are also disorders that cause lengthened bones. So Marfan syndrome causes long limbs because of excessive cartilage formation, okay, at the epiphyseal plate. Remember, that's where long bones grow from. Okay, so it causes like long, slender limbs. Gigantism is overproduction of growth hormone. So Andre the Giant, the famous wrestler, had gigantism. Okay, so it can be treated by medications that suppress growth hormone. Okay, osteopenia and osteoporosis. These are where bones become brittle. Osteopenia is not as severe as osteoporosis. So osteopenia starts a lot younger, between 30 to 40 years of age, and both of these affect women more so than men because of menopause, and women have smaller bones than men on average as well. Okay. So osteopenia would result in fragile limbs, okay, and reduction in height. So older people, if they start to kind of shrink, that can be due to osteopenia. Osteoporosis is more of a severe bone loss. So you'll see the spongy bone in the PowerPoint has a lot of holes in it. Okay, so it's become a lot more brittle. Okay, now I'm going to get into chapter 7, the axial skeleton. I'm just going to go over a few things from the PowerPoint, and then I will make a video going over the different bones and bone parts using the models in class. Okay, so you can see all of those, and I'll go over some more information as I go through those as well. Okay, so we have an axial and appendicular skeleton. The axial skeleton is made up of 80 bones, so it's like the axis of the body. So the bones of the head, the vertebrae, the ribs, sternum, and the sacral bone, which is the bone in the back of the hip, make up the axial skeleton. The appendicular skeleton is made up of 126 bones, and it's the appendages and what attaches them to the axis. So it'd also be the clavicle bones and the scapula bones, which are like the back shoulder bones, and the coxal bones of the hip, which attach the legs to the axial part of the body. Okay, so you should know that there are 80 bones in the axial and 126 in the appendicular skeleton. Okay, all right, so let's talk about the shape of bones. So there are 5 main shapes. Long bones, which are longer than they are wide, so these would be all the bones in the appendages. Short bones, which are more like cube shaped, so these would be like the bones in the wrist. They're like little cube shaped bones. Flat bones, they have thin layers of parallel plates. So these would be like the cranial bones, the coxal bones of the hip. Irregular bones, these have a complex shape to them. So these would be like the vertebrae. They don't fall into any other category. And then finally, sesamoid bones, which are shaped like a sesame seed. So this would be like the patella bones, the kneecap bones. Okay. Okay, I'll talk about the sutures when I get to that. So there's bone surface markings. There's markings on the bones. These could be openings for nerves and blood vessels. It can also be depressions and areas for muscle attachments, okay? So we're gonna just talk about the general names that you'll find in bone surface markings, okay? So you should know in general what these words mean, okay? All right, so a fissure, this is a narrow slit, so usually this is for like nerves, okay? A foramen is an opening, okay? So we have a foramen where in the occipital bone where the spinal cord passes through, so a foramen is a rounded opening. A fossa, this is in a shallow depression, it's like a shallow indentation. A sulcus, okay, this is a groove. Okay, a meatus, this is a passageway. So we have one near your ears, the auditory meatus, okay, external auditory meatus. A condyle, this is a large round thing that sticks out, a protuberance. Okay, a facet, this is a smooth, flat, concave or convex surface. It's an articular surface, so where a bone can attach or a muscle can attach. A head, so our long bones have a head, so like our femur and our humerus, for example, have a head that attaches into a socket, so that makes a ball and socket joint. A crest, this is a prominent ridge. Okay, epicondyle is like a line that sticks out. A line is another type of line. Okay, spinous process, this is a sharp projection, so we have spinous processes in our vertebrae bone that stick out in the back. A trochanter, this is a large projection, something that sticks out. A tubercle, this is a rounded projection, it could be different sizes. Okay, and a tuberosity, this is also something that sticks out, but it's going to be like rough. It's not going to be a smooth projection. Okay. All right. Okay, so that's it for this video. I'm going to go over the all of the bone names and parts in a different video.